Assalamu alaikum students. Today we shall continue with the past paper practice and in this class we will start question of organic chemistry from 2019 Feb March exam series and paper 1-2. The first question is how many structural isomers are there of trichloropropane? So this is the name of the compound and this is its molecular formula, and we are supposed to find the number of isomers, which are structural isomers of this compound, which we have to find. So to determine that, we definitely need to draw the structures of the compound. So I will separately draw the structures here and find out the answer. Now for this purpose, the structure will be like this. We have 3 carbon atoms because the actual compound contains 3 carbon atoms. Now on these 3 carbon atoms, I just need to identify the position of the chlorine because 3 chlorine atoms are there and they are the only thing which we have to differentiate. So chlorine over here, chlorine over here, and chlorine over here. So this is one isomer, and you can also find the higher number of hydrogen atoms which will represent this molecular formula. We will have 2 hydrogen atoms on the left carbon, 1 on the central, and 2 on the right. So in total, we will have 5 hydrogen atoms. So this structure belongs to this molecular formula. Now I have got one structure over here. Now this one structure is basically considered to be first isomer. Now I will draw another isomer. The other isomer will again have 3 carbon atoms. I am going to draw another structure. I have 3 carbon atoms, but this time the position of the chlorine atom will not be changed. This time the chlorine atoms will be like this. The left carbon will have 1 chlorine. The central carbon will have 2 chlorine atoms, and the right carbon will have no chlorine. This is my second isomer. Now another isomer, again 3 carbon atoms. Now on these 3 carbon atoms, I will show all the 3 chlorine atoms on the left carbon. So left carbon has all the 3 chlorine atoms. This is my third isotope. Now another arrangement, 3 carbon atoms. Now this time the chlorine atoms, there will be 2 chlorine atoms on the left carbon, 2 chlorine atom on the left carbon, and central one has 1 chlorine atom. Now you can match these 2 isomers. They are different from each other. These 2, the second and the fourth. In the second isomer, I had the 2 chlorine atom on the central, but in the fourth isomer, I have 2 chlorine atoms on the left. Now this will be similar to another isomer if I put 2 chlorine on the right carbon instead of the left carbon. That will resemble the same compound. So I'm not going to draw that compound here. Okay, now I have 4 isomers now. Now fifth isomer. For the fifth isomer, I need to draw another compound of 3 carbon atoms. Now here in this case, the chlorine atom will be distributed like this. We have 2 chlorine atoms on one carbon on one side and 1 chlorine atom on the carbon on the other side. So this is a different arrangement of the chlorine atoms on the carbon atoms. Now in total, I have got 5 isomers. So there is no any other arrangement by which I can get another type of the isomer on the basis of the arrangement of chlorine atoms. So in this way, my final answer is C, having the 5 isomers. Now, the next question number 21. A sample of a compound L had a molecular formula C10H16. A sample of L reacted with an excess of hot concentrated acidified potassium manganate. Compound M is produced. What could be the structure of compound L? Okay, so for this purpose, I need to find which compound among these 4 options is the right compound, which reacted with the hot concentrated potassium manganate to produce compound M. Okay, so if you look at the M structure and compare with the given options, we can find that the part at the below, which is at the bottom of the structure, it is that part which resembles like this part. So we can identify which of these 2 structures is the same, because these 2 structures are repeated in C and D. So one of these 2 is the correct one. So if I look closely here, I have a ketone part over here, and the reaction of hot concentrated KMnO4 with the given parts is alkene. So reaction of alkene with hot concentrated KMnO4 to produce a ketone. We have alkene over here and we have the alkene over here, both sides. But this alkene has the structure like this: carbon double bonded with carbon and 1 carbon below, and then structure of the benzene like this. Whereas this one has a structure like this: carbon bonded with this carbon, double bonded with carbon, and then the structure of benzene over here. Now I have to consider that which of these 2 compounds will be reacting with the KMnO4 to produce the ketone over here. So if I look closely here, then we should remember that when KMnO4 attacks on the carbon-carbon double bond, it produces the carbonyl group. So carbonyl group will be produced over here as a result of the reaction of KMnO4 and the alkene. The carbonyl group will be produced here. Whereas in the case of this structure, the KMnO4 will attack over here, and it will be producing the ethanoic acid from these 2 carbon atoms. Initially, it will be ethanol. Initially, it will be ethanol, and then it will convert into the ethanoic acid. And the upper portion of the carbon will produce another part, which is which over here will be the carboxylic acid again. It will produce carboxylic acid, COOH part. So these 2 are not actually the compound matching in the compound M. Whereas this one is, because this produces ketone, because carbon-carbon double bond was converted into the ketone part. So I can say that this side is basically the right side, this one, and similarly on this side, both C and A both have these right structures. Okay, now this is clear from here. Now I have to consider the other part from here, which is the formation of this long chain. Now this long chain must be coming from the benzene structure, because no other key option is given apart from these benzene rings. So that means it has been broken off by the reaction of the KMnO4 on the benzene ring. Now what I see here, that In this compound M, I have the ketone part on one side and carboxylic group on the other side. So we have to consider which group can produce these two functional groups. So if I look closely, we have two different combinations. These two are same and these two are same. Okay, just looking at one part at one time, I will consider the left side. So if it is cleaved from here, I will get the ketone on this side. Ketone will be produced on this side, and then the right side, which is basically having one hydrogen atom over here. There is one hydrogen atom here, and there is no hydrogen atom over here. This side, it has all the four valences completed by carbon-carbon atoms. No hydrogen atom is there, but there is one hydrogen atom on this carbon over here. So this hydrogen will initially produce the aldehyde as a result of the reaction, and then it will convert into the carboxylic acid. So carboxylic acid is produced here. So that gives us a breaking apart of this point to make a straight chain along with the formation of the ketone on one side. So ketone will be produced over here and carboxylic acid is produced over here. So we have carboxylic acid and ketone. But if we consider the other structure type, which in this case, we can see that it will produce the carboxylic acid because there is hydrogen atom over here and this one another hydrogen atom over here. So both of these parts will produce aldehyde first and then carboxylic acid, which means there is no formation of ketone. We required ketone on one side, but there is no formation of ketone over this point. So as a result of this, we say that this cannot be the right one. So we have this point to be the right. Now, this is a right part. Both of them have the right portion of the upper portion. But you can see that there are now two ticks on this compound, which means that the right option is A option. So in this way, we have found the right compound, which is producing the structure M. Now, next question number 22. Question number 22 says, many reactions take place in the engine and catalytic converter of a car. Which pair of substance is produced both by the reaction in a car engine and in a catalytic converter? All right, so in this question, we have to find out the right product which are produced by the catalytic converter and by the combustion. Now, if we remember that carbon dioxide does produce inside the car engine as well as by the catalytic converter, because catalytic converter will produce carbon dioxide, it will produce nitrogen gas, it will produce water. So these will definitely be produced by the catalytic converter. Whereas reactions of the car engine can also produce carbon monoxide, carbon dioxide, it can produce water, it can produce unburned hydrocarbons. I will write UHCs, unburned hydrocarbons. So, and also the from the given option, we have these compounds. So carbon dioxide is produced by both the catalytic converter and inside the car engine. So carbon dioxide is present in both option A and B, and water. Water is produced both by the catalytic converter and by the engine. So water is produced, but there is no water in any other option. So this leaves us with the correct option to be question number with the option B of question number 22. Now the next question number 23. Now, question number 23. The statement says structural isomerism and stereoisomerism should be considered when answering to this question. 2-bromopentane is heated with an excess of ethanolic sodium hydroxide. How many different hydrocarbons are produced? Okay, so for this purpose, we need to first have this compound shown in the form of structural formula. So I'm going to simplify this structure by showing the carbon atoms and the position of the bromine with this symbol. So 2-bromopropane means bromine is present over here. Now this compound is reacting with the excess of ethanolic sodium hydroxide, which means the type of the reaction is of elimination reaction. So elimination reaction will be there. Now, how do we find the products of the reaction? First, you should remember that according to the rule, the elimination will be definitely of the bromine. Bromine will be removed from here, along with the removal of hydrogen. Now, the hydrogen which will be removed can be from this carbon, or it could be the hydrogen of the next adjacent carbon atom of here. Hydrogen of this adjacent carbon or the hydrogen of the previous carbon. So initially, I will remove the hydrogen of the left side. So this hydrogen along with this bromine. When this will be removed, then you will get the new compound, carbon, 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 5 carbon atoms. Along with that, I need to indicate the double bond between these two carbon atoms because I'm removing the hydrogen of this carbon and bromine of this carbon. So double bond will be produced here. So this is a compound form here. But this is not the only case. In the other case, the removal of hydrogen will be the other carbon atom from here, along with the removal of bromine. So I can say that in this case, the structure formed will be shown like this: carbon, 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 3, 4, and 5. So 5 carbon atoms, and then the indication of double bond. Now in this case, the double bond will be there between these two carbon atoms because we have removed bromine and hydrogen from here. So I need to indicate the double bond here. Double bond will be produced between these two carbon atoms. Okay. Now the next, I have got these two compounds. If you look closely here, we have double bond between these two carbon atoms and double bond between these two carbon atoms. This next structure. They said that you have to consider stereoisomerism as well, which means you can consider cis trans, or you can call them geometrical isomerism. And the second part is optical isomerism. Now, optical isomerism is not there in any of these two compounds because we have no such carbon having the asymmetric or chiral carbon because there are no 4 different group of atoms attached on any of the carbon atom in these two structures. But we can consider the cis trans. The cis trans, for the condition required for cis trans drive, we should have double bond. So there is no, since there are 2 hydrogen atoms on this carbon, so it cannot produce cis trans. But for the lower structure, we can have cis trans because there is an alkyl group over this side and there is another alkyl group of this side. This is also methyl group and the other one is an ethyl group. But they are considered to be same functional group in that sense that we have hydrogen atoms over here and hydrogen atom over here. So if I consider this type of the structure, this will be the cis. This isomer will be considered cis. But if I change the position, according to this way, that I consider the hydrogen atom, one hydrogen atom is above and the other hydrogen atom is below, like this. Now at this time, the alkyl group of one carbon will be upward and that of the other carbon will be downward. So that will produce the trans form or trans configuration. So I will have cis and trans from this compound. So in total, how many isomers will be there? First, this will be the one isomer, and this compound having double bond between these two carbons is considered to be second, but at the same time, this second could either be cis or trans, one of these two, which means I can assign two to this cis or two to this, but I have to assign one at a time. For the time being, I'm assigning cis as a second isomer, and trans will be assigned the third isomer. It will be the third isomer. Now, so we can see here that we have now in total three isomers. First, and this whole is considered to be second because this second structure can either be one of these two. It could be cis or it could be trans. If it is cis, then the other isomer will be trans. So in this way, the correct answer of this question is option C, three isomers. Now, question number 24, bromine reacts with water as shown. We have this reaction. The bromopropanes reacting with the water to make this compound along with HBr. Which statement is correct? So if we look here, this is an elimination reaction. No, it is not an elimination reaction. How can we see that? Because two reactants are reacting with each other to make two products. So nothing is being eliminated extra over here. If there was initially one reactant and the formation of two products, then that could be considered to be the elimination reaction. You can consider it like this: P plus P, P1 and P2, product 1, product 2, and one reactant here. But it is not like this. And in other way around, you can also see that the Br is replaced by OH over here. It is the replacement, it is the substitution, it is not the elimination. So this is not an elimination, instead it is a substitution reaction. B says this is a hydrolysis reaction. So hydrolysis reaction does occur here because we are using the water. Hydrolysis means a reaction carried out by water in which the other compound is broken and a new product is formed. So, and as a result, water itself splits. So water is splitted here and it has produced a new compound that considered with the hydrolysis. Why? What about C? This is a redox reaction, so you do not see any change in the oxidation number of any element. So it is not a redox reaction. It is a not redox reaction. It should be. The D says this reaction tends to proceed by the SN1 mechanism. Now this is a primary haloalkane. So primary haloalkane goes through the SN2 mechanism, not by SN1 mechanism. So that's why it is incorrect. So the only right option is the B option. Question number 25. The question 25 says, which product is formed when 3-methylpentane 1,3,4-triol is heated under reflux with excess of acidified potassium dichromate? Okay, so first for this purpose, we need to draw the structure of the compound, which is the 1,3,4-triol. So I'm going to draw the structure of this compound. I have I have 5 carbon atoms, 1, 2, 3, 4, 5. Then I need to indicate the presence of methyl group, which is on position number 3. It could be from left to right or right to left. Both will give you same. So methyl group on the third carbon atom. And then I need to indicate the position of the triol, which means having 3 hydroxyl groups. Now at which position? At position number 1, at position number 3, and then at position number 4. So I have now 3 hydroxyl groups attached. Now, the next part is that I have to react with the acid potassium dichromate. Now, this is basically an oxidizing agent in this case. So what will happen? This oxidizing agent will oxidize the hydroxyl group into the carboxylic group or aldehyde group. Initially, according to the situation, we know that primary alcohol is converted initially into aldehyde, oxidized into aldehyde, and then it is oxidized into carboxylic acid, according to the literature. The secondary alcohol is oxidized into the ketone, and tertiary alcohol cannot oxidized, no reaction. So we have to consider accordingly. Now the first carbon, if I say this is first carbon, yes, it is a first carbon, so it should be converted into the aldehyde and then into carboxylic acid. Now the carbon number 3 is basically that carbon which is bonded with 3 more carbon atom, which means that this central carbon is basically the tertiary carbon. So you can consider it as a tertiary alcohol. So this OH will not be giving any oxidation product. It will remain there. It will not convert into aldehyde or ketone or carboxylic acid. It will remain the same. Now, the carbon on position number 4, which we know that this is the 4th position. Now, this 4th position carbon is basically that type of carbon which is connected with 2 more carbon atoms, which means that this is a secondary alcohol. So this is a secondary alcohol which will convert into the ketone. So you will get ketone over here. So ketone is produced here, no product on the third carbon, and for first carbon you will either get aldehyde or carboxylic acid. Now we will select the right options from the options A, B, C, D. So if you look at option A, we have the carboxylic acid on one side, which we can consider this is the carboxylic acid. So yes, carboxylic acid will be there in both option A and option B, and then option D. All of them have the carboxylic acid, but not the option C because it is the alcohol. It is it is the aldehyde part. This is aldehyde, not the carboxylic. So this is aldehyde. So C cannot be the right option. Now, if we go forward, we said that the carbon number 3 produce no product. So which is the carbon number 3 over here? 1, 2, and 3. This is a third carbon. On this third carbon, we have the CH3 group and the OH group. So yes, we have the CH3 group and we have the OH group. So we can say that this will be the right product because OH was not oxidized. So it is not oxidized here. It is not oxidized here, but we have no option in B and D to be the right product because option B said it is converted into ketone, which we saw previously that it was not oxidized. So it is wrong. So it is wrong, which means B is also wrong option, and definitely D option as well because D option also says ketone, which is wrong. So D is also wrong from here. Definitely we can find that A is the right option, but still we need to discuss some more thing. The last carbon, sorry, the second to last, which is carbon number 4, had OH had the OH, and that fourth position carbon was basically secondary alcohol, which should produce ketone. So if we look here, this is the ketone. This is ketone because we have CH3 on right side and we have carbon on this side. One group is present here. This is one group. And then this is the next carbon of this side having OH and CH below. So this is the other alkyl group. And that's a central carbonyl group. So this is the right structure, but we do not see in option B, but we do see in option C, because CH3 on right side and then this carbon which is indicating alkyl group. So that is right, but it is already crossed. And D option, the D option is also correct because it has alkyl group on one side and it has the carbon of this side. This is alkyl group, but it was crossed out because it showed the formation of ketone. That was wrong. So it is correct over here. So considering that we have now 3 ticks on this only option A. Option A had 3 ticks. If you could start it from right to left, then you would need to cross out the wrong parts. But I have started from left to right. So I have pointed out which are the right structure and which are the wrong. So A is the only option with 3 ticks. So that's why A is a right answer. So that was for these questions.